Thank you so much, Wes. Following up a presentation after Andy is going to be a tough task because of the high bar he set. So I'll try my best. So first and foremost, thank you all for joining. And I just want to thank AIM, Zamba, and VSF and the IP Oktoberfest team to give me an opportunity to share some of the work that we're doing with customers around the world. Now, I know for those of you who I haven't had a chance to interact, my name is Rahul Parameswaran, and I'm a principal engineer at Cisco with the cloud networking team. And I focus on the media and entertainment vertical. And over the last 4 years, I've been working with customers to transition their facilities from SDI to IP. And along with that, of course, I've been working with a lot of our partners in enabling that transition. So over the next 20 minutes, again, keeping it very high level, I would like to share, as our customers are deploying this IP-based facilities, right, for carrying either compressed or uncompressed traffic, we did come across a challenge with regards to addressing and IP addressing. And my goal is to show you how we went about solving some of these challenges. So having said that, that's essentially what we're going to be talking about today is do a quick recap on network address translation. I'm sure most of you all know it, but no harm in just doing a quick recap. And then we'll just go down into use cases, right? And that's the goal. So like I said, right, if I have to do a quick recap on network address translation, very, very likely all of us, as we connect to the internet from our homes or from the office, we are using network address translation, right? So the most common type of network address translation is where you have a unicast IP and unicast communication. So this is, say, me communicating to Zoom over this webinar. I have a unicast IP. My target is a unicast IP, and my router converts that to another set of unicast IP, right? And it's transported elsewhere in the network. So this is a common use case of Unicast NAT. And then as we start introducing multicast, right? And so multicast traffic is extremely important when it comes to delivering media streams. The source IP is, of course, is that the unicast IP of that source or the sender transmitting the feed. And the destination is that multicast feed where multiple receivers can subscribe to. So in multicast NAT, like I've shown you here, we are translating the destination multicast group from one to another, and you also have the ability to translate the source. So it's not like you only are doing one part of the address translation at any given time. You can translate both the source IP to a different unicast source IP and the destination IP to a different multicast destination IP, like I've shown you in this diagram. And finally, the other way around, right? You could have this is where service reflection really comes into play, where the original stream could be purely multicast, and then you convert that to unicast. So there are some use case and reasons why someone may need to do it, and this is what falls in the service reflection category. And the last thing I don't have on the slide is the other way around, right? You have a unicast feed that you want to convert to multicast. That's all of these conversions. Like I said, it might just be a little overwhelming for someone hearing this for the very first time, but there are reasons why all of this will become something that you would have to consider yourself as you're building these facilities. So having set the stage of what NAT is and what multicast service reflection is, let's look at some of the use case that we've come across, as like I said, while we're building these facilities. Oh, before that, yeah, one quick, because these are some of the terms that you would come across while you're reading some white papers, design guides, discussions, is ingress versus egress. So think of Ingress NAT as you are translating the flow before it, as it enters your facility, right? So every destination within your facility would only see the post-translated flows. So that's called Ingress NAT. So you do the translation as it comes in. And again, Egress NAT is the other way around. So you have your flows within your facility, and you say when you're handing it off to a different facility, to a different, someone else outside the facility, then at the border or the edge of your facility is where you do the translation. And that's what we typically refer to as Egress NAT, right? So, and that's, again, these are terms just so that we're all aware when I bring up these terms in these use cases. So the first use case, this became very obvious. In fact, during the Olympics itself, right? When some of our customers were on site in Tokyo producing the Olympic Games, and they were getting feeds from different parts of the network and ingesting it to their own production fabric. So one thing that can happen is that, I just want to take a step back, right? So when you have a production network built using, COT switches that's running multicast routing, these switches have, they have a feature called reverse path check, right? So every time we get a multicast traffic, this applies to most COT switches that's running multicast routing. They do a reverse path lookup. They look at the source IP address of the feed and make sure that those sources are directly connected to it. So for example, if that interface had a subnet of 192.168.1.0, like /24, then it, by default, it expects all traffic that enters into that interface, especially multicast traffic, to belong to that subnet. Now, this is something that is not within your control, especially when you're getting feeds from different providers and different facilities. So the first thing you do is you tell the switch to ignore that check and say that, hey, even though you're getting the traffic from that does not match your interface IP's broadcast network or subnet, continue to accept it. So it accepts it, but also you could run into a scenario because, again, you have no control as to what kind of IP addressing scheme the other end they're using as they send you the stream. You may run into a situation where the IP address used by these remote sources overlaps with some of the IP addresses that you're using for an internal workflow. So this actually happened, and then you could do one of two things, right? You can just call the person who's sending you these flows and say, hey, can you please change the IP addressing scheme because it overlaps with something that I am running within my facility, which we all know is not that straightforward. So this is what I call the first use case of where an Ingress multicast NAT would be very, very useful. Because if I did not care about what addressing scheme an external entity is using to send me those feeds, I can leverage this functionality to translate this address, the external address, to an internal address. Maybe in this case, I translated G1, G2, G3, which were the original multicast groups, to G10, G11, G12. Now, what this becomes is that this G10, G11, G12 it's almost like you have net new sources within your facility that then you can route to any destination within your facility. So this is one common use case of Ingress multicast NAT that, like I said, we ran into, with multiple customers as we're going end-to-end IP. And this is how we go about solving it, right? And I asked this question, right, saying that, hey, well, if I'm getting a feed from a different facility or across different buildings, am I not just going to compress it and while I compress it, that is the time I would change the IP address? Well, the answer is yes, but oftentimes you don't have. It's not like the same entities own either ends of the facility, right? So you may not have control of what's going on out here. And nowadays, with the fact that we are going into an end-to-end IP model and the bandwidth becoming less expensive, we are seeing customers sometimes even do uncompressed transport of 2110, directly from one facility to another. So again, right, just keep this in mind that you would definitely start running into this as we see more and more people adopt IP, and yeah, we don't have a choice but to leverage some of these features to overcome this challenge that we came across. Now moving on, what happens when in the other, now we'll just flip things around, right? Like you have your own facility that you are producing certain shows, events, and then oftentimes you want to send that out across buildings, maybe to a different production control room, or you're handing it off to third parties. And this is where the Egress NAT translation comes into play. So the advantage of Egress NAT translation is that you can pick and choose any source within your facility. And then as you hand that source, to other facilities, again, for several reasons, right, you may want to be considering doing Egress NAT. So one thing is customers are not comfortable sharing the addressing scheme, right? Maybe you don't want to expose what kind of addressing scheme you're using within your facility to produce your shows. So you want to change that as you hand off content to third parties or different facilities. Or maybe, like I said, this could also be another way to address that address overlap, right? When you know that this particular group is already used somewhere else, so that gives you an opportunity to translate it. But this is translating it as it egresses your facility. And the good thing about this feature is that these, like I said, sometimes you don't have control about what the other facilities are running, right? This could be an OB truck, this could be a remote facility, a third party. So you do not want to, you don't want to be dynamically exchanging any kind of control plane communication between your facility and the external facility, because almost no one wants to extend their, for example, if you're running IP networking, your Unicast routing or multicast routing, or you don't want to be exchanging that. In fact, sometimes we run into a situation where one facility is running, like an IP protocol, the other facility is SDN controlled, different controllers. So, you don't have one common entity controlling both of them. So this, without these facilities dynamically requesting, hey, why don't you send me this group? We have the ability to use egress natting to send them, different multicast group. And the advantage is at a certain time of the day, for example, at 10 o'clock in the morning, you want to send this S1G1 to facility 1. The facility 1 is fixed, right? It is only going to be listening to S10G10. So at 10 o'clock, you route S1G1, you convert that to S10G10 and send it to this facility. But maybe at 3 o'clock, you want to route S2G2 to that same facility. So it's dynamic, right? You can go and modify the NAT rules such that you remove the original translation that was converting S1G1 to S10G10, and then you create a new translation that converts, say, S2G2 to S10G10. And that way, you are not dependent on informing the third party that, hey, they have to listen to a different multicast group because we are now going to send you a different feed and so on. And this is essentially what, again, we've seen customers do as they hand off contents to other facilities. And last but not the least, as this comes across as something that we always have to remember, is that your network, especially when you are handing off content to multiple other third parties, your network should never become a transit network for these entities to talk to each other. And this is something that we all have to be careful and not facilitate that. Now, there are features within any network switch that allows you to apply a policy as simple as, like access control list, that a security list that prevents any communication, that you don't even have to entertain anything coming into your facility because it's only an egress or an outbound communication. So again, these are some of the best practices, right? Along with the fact that we're doing multicast natting, we can also apply some security policies to ensure that you don't become what I call a transit network. So this is a common use case where we've seen the egress multicast NAT come handy. All right, so moving ahead. Now, I know Andy briefly spoke about the initiatives from ground to cloud, cloud to ground. There's a lot of interest amongst the industry, our customers, on how do we enable such workflows. Now, today, most of all know that these cloud providers have limited, or I should say no support for multicast traffic. Now, typically, when you hand off content to the cloud providers, for most part, yes, you end up compressing it, encoding it. So there is a device that could potentially, as they encode it, translate multicast to unicast and hand it off to cloud. But just think of some of the workflows that may become possible in the future, where you don't need to do any kind of encoding. What you could do is leverage the service reflection capability on the network switch. Now here, you see I've used the term service reflection instead of NAT. And typically, again, when you read a lot of white papers and design guides from any vendors out there, the term service reflection is typically used when you go from unicast to multicast, or multicast to unicast, and vice versa. So in this scenario, like, we know that our cloud providers don't support multicast traffic. This feature can take any multicast flow, right, coming from S1, G1. You can convert that to unicast, right? And then it simply follows your unicast routing table that says, okay, how do I get to this destination? So these destinations, just follows the unicast routing table to either go to the public cloud. And that's how you see we've leveraged. And all of these features that I'm talking about is not something that's net new. In fact, I think 10 years ago, switches supported multicast service reflection. But all of these use cases are, which were well used in other verticals across, other customers, become very useful for the vertical that we are all in. So that's why it's important to know the capabilities of most switches, is that you have the ability to do this. So this is, again, a typical use case of the service reflection, where we can take multicast, convert it to unicast, and ship it right to any entity that only understands unicast. And this is not just limited to the public cloud. We also ran into this as customers started interconnecting their facilities, right? This is, we had a huge esports customer who do remote production of shows. The show could be happening in Iceland or in China, but produced in the studios in LA or Amsterdam. And they have their own private WAN networks. It's a high bandwidth WAN network that have the ability to interconnect multiple facilities. But you will always run into a scenario that the WAN simply doesn't allow multicast transport, because again, there is an element of operational complexity to insert multicast over WAN. I mean, it's possible. I'm not saying that it's not possible, but there could be scenarios where customers have not implemented that because they never created the WAN. The WAN was created several years ago without even knowing that there would come a day where they would have to transport uncompressed video or even compressed video multicast over the WAN. So you may not even have multicast routing enabled over the WAN. And this is where the multicast to unicast translation can become very handy, right? Because at the edge of a facility, if you can take that multicast signal, convert it to unicast, now you're good, right? Because the WAN understands unicast. For the WAN, it's just going to be unicast transport of this traffic and send it across the WAN. And as the traffic enters the other facility on the other side of the WAN, and this is why you're going to do the multicast service reflection. Now you're doing the reverse conversion, right? You're converting unicast back to multicast. So essentially you can do that. And then any destination within this facilities, you can route the signal because it's multicast. So you see how all these features that were common several years ago are coming into play now as our customers start building, or rather leveraging end-to-end IP production. So that's at a very high level, right? We saw use cases with Ingress Multicast NAT, Egress Multicast NAT, then multicast to unicast service reflection, and finally unicast to multicast service reflection. So that pretty much covers, what I call the most common use cases where I have seen customers leverage this functionality to kind of, overcome all of those challenges that I spoke about. Now, yeah, this is another case where unicast to multicast translation again works, but I think we all get it from that previous example as to what some of the use cases are for that unicast to multicast translation. Now that we've seen all that use cases, I want to just talk about this use case now, and for that, again, I wouldn't say is very common, but something, because I've seen this happen, I want to share it with you, is you could run into a scenario, especially as customers are building production facilities. There could be some legacy devices. I call them legacy destinations that maybe the broadcast controller does not have the ability to control. It's just probably because it doesn't support ISO 5 as an example. But what happens when you have to route different sources to that destination, right? And this is, I would say, one scenario again where that Egress NAT, helped. So leveraging the egress, so it's no longer sending traffic outside your facility. It's still within your facility to a local destination, but yeah, this destination is like a legacy destination that you simply cannot control. So you can use Egress NAT, for example, at time t0, I'm routing source 1 to that destination, and at time t1, I'm routing source 2 to the destination, and at time t2, I'm routing source 3 to the destination. And you are, see, every other destination within the facilities can continue to receive the original traffic coming from these sources. But for this legacy destination that we are unable to control, it's just locked to a single source comma group. We still have the ability to route different sources to that destination, right? And one of the most common questions, I always get when I share this with our customers is that, hey, can we use this to do routing, right? And my answer is no, not really, right? Because we only see this as corner cases, like I said, with legacy equipment. But I would say 95% of the deployments that are happening today, you're very likely getting brand new gear from variety of vendors that can be fully controlled through ISO 5. So that is what we see most customers end up doing. But again, right, this unblocks some of the legacy installs and allows customers to make use of some of what they have without having to simply discard it or find other creative ways for making this happen. So like I said, just use this as a corner case scenario, but not something that you can do at large scale, right? And then this is another clever hack that one of our customers did. I'm just showing you, again, these are not common use cases, but something that becomes available when you have multicast NAT. In most production facilities, we have the red and the blue, the X and the Y, the two networks, for 2022-7. But if you have a source that's single homed, you can get a little creative. And this is where you can leverage, let's say, a box, connect the source behind it, and create two streams, right? One sent to the A, the other one sent to B, and so on. Again, not very common at all, but ideas that I can think of as to hey, how you can solve some of these challenges with single home hosts. But again, while this is helping a little of ensuring that we have two copies of the streams across both the networks, so it accounts for any kind of network failure that can happen within each network, such that this destination continues to receive two copies. But at the end of the day, it is still a single point of failure, which is that source or this switch, right? So it's not, which is why I think this use case is not very common, but I've seen people use this. So that's, again, right, very quick recap of other use cases, which in my opinion are corner cases, but again, something that could come to your rescue in those scenarios where you have to use them, right? And that's pretty much, if I have to I had another slide, I forgot to, yeah, like a conclusion slide, right? But what I wanted to call out was that, these features, again, were extensively used across other verticals. But just remember that the capability is does exist on networks, and as and when you see more and more of our customers leveraging these workflows, right, it becomes these capabilities come into play to really unblock them from these use cases. So with that, let's see, how am I doing with time?
You're doing great, Rahul.
Okay, perfect. That's pretty much it, Wes. Again, right, I think I've covered everything I wanted to cover. So in conclusion, yeah, I'm happy to take any questions or comments from our attendees.
So I did have one question, Rahul. Any thoughts on what we're going to do with session description protocol when we're doing these translations? Are there some, is there some guidelines that you've come across for people to make sure that the SDPs get converted properly? Or is that a manual process?
It is a manual process, and it's pretty much because a lot of these translation, especially when you look at a use case like this, it is controlled by the broadcast controller, right? Not the network is just providing an interface for them to do it. So it is the broadcast control. Again, this is outside my expertise, to be honest, where they take care of ensuring that, that if they have to make some manual changes, it's all done there.
Okay. All right. And then just other real quick, I'm aware of some long haul video transport providers that provide, sort of NAT translation within their network. Is that a good idea or not?
No, I mean, like I said, they do. In fact, that could be an additional service that they can provide. And I don't see any reason why that's a bad idea. But but what we are also seeing is that a lot of customers are, it could be within your facility and you're interconnecting two buildings, or it's going through a service provider that does not have that capability. And that's where some of these features come in. And they are doing the exact same thing, right? It's another switch or some device within that facility that's providing this functionality. So